So it's time for the V-TAC lamps out of Poundland. Oh, I've just noticed something quite interesting. Very interesting indeed. This is one of the GU10 lamps, and it really is heavily glued together. How do we go at the glass? It's really glued in tight. It's going to be a smash job, but it's well glued around the outside as well, so it's going to be totally destructive. However, I do see in the back, through the clear area here, that it's got this typical capacitive dropper arrangement in the back. It's just all the components are just completely visible. Plus, something quite odd for this type of lamp, it seems to have an air vent through the glass here and here, so it's designed to get at least some sort of airflow. Or just maybe that's thermal expansion. Or maybe they're vent holes for when it blows up. That's a possibility, because otherwise it'd blow the front out of the glass, wouldn't it? They might be vent holes for the explosion. Excellente! Suddenly it's gone up in my expectations, but also down because I'd rather it went bang, but not to worry. So let's, given that this one is so glued shut, I'll refrain from smashing it right now, but inevitably will at some point, but I'll put it out of the way at the moment. And we'll look at these ones. So this is the candle one, which I've already popped the lid off. And the lids are plastic. This one is still glued on. Well, I hope they're plastic. And glued on really well. It took a modest amount of effort to get the other one off. Let's see if I can impale myself with a screwdriver. This is highly dubious. No, that is really rock solid. I'm going to need the vise to get that one off. But anyway, let's look at this one. So this was the candle-shaped one. It's rated 6 watts, and it seems to clock in round about that power. Let's not take my word for that. Let's plug it in and refresh my memory. Is it really 6 watts? In goes the meter. Plug it in. It's very bright. 5.9 is pretty damn close to 6, so let's say 6 watts. This is a bright light. It's very bright indeed. So let's check out the voltage across this, and this is where it just gets very bright. I'm going to have to put on the shades for this. And we'll bring the meter in. It's set to 200 volts, it'll do. And let's measure the voltage across these terminals. Keep in mind this is probably referenced to the mains, because it probably is just some beefy capacitive dropper. I'm not sure polarity because I can't actually see anything right now. So we're getting 86 volts. So based on that, we can calculate the current through the LEDs, assuming 100% efficiency, which is not going to be. The current through the LEDs, 86 volts, P equals IV, I equals P over V, so that's 6 divided by 86 volts equals, the current through LEDs is going to be about 70 milliamps per LED, but was that 86 volts I said? I think it was. So there's 1, 2, 3, 4, 5, 6, 7, there's 14 LEDs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 86 volts divided by 14 LEDs equals 6 volts. So there's going to be 2 chips in each of these LEDs. So that dissipation then, if it was roughly, did I say about 60 milliamps, or was it, oh hold on, I'm going to have to do that again. 6 divided by 86. Yeah, it's about 70 milliamps. So that's 70 milliamps times the dissipation is going to be roughly 6 volts equals roughly 0.4 watts per LED, which seems a lot for these tiny little packages, doesn't it? But let's open it up and see if it is a capacitive dropper inside. Screws, which is interesting, it's not just glued in. Oh, that's interesting. It's an aluminium plate behind it with heatsink compound. I'm going to have to get destructive here. Very destructive because it's glued in. Probably for thermal transfer. Oh, that really is glued. One moment, please. Jeez, that is really well encapsulated. There's a aluminium sort of sub chassis here that supports the LED PCB with heatsink compound, and then that's gooped onto the aluminium interior of this. And then, rather interesting, there's a little power supply. Let's hike that out, shall we? That was really tough to get out. I wouldn't recommend that. I'm quite surprised there's not blood involved, because it really was lots of sharp aluminium and really lots of goop to hold it together. So very, very tough to open. So what we got here? Doesn't look the usual thing, but I could be wrong. Okay. Oh, blimey, it's got an interesting little chip in the back. Tiny little transformer. I should be attempting to see if I can short out that capacitor before I start poking about anymore, so I shall do that. Like this. Yeah, that looks pretty dead. So, what's this chip? The chip is... It's got a big square right across the middle of it. That's quite annoying. The chip is quite hard to read. I'm going to have to read that and put a note up to tell you what it is, because it's sort of laser engraved, plus it's got a score down the middle of it. So it's got the rectifier, it's got a diode there, it's got the smoothing capacitor. So is it a buck or a standard? It's got a very small, it looks more like a choke. Oh, it is 7.5 millihenry. This is a buck regulator by the look of it. It doesn't look like the standard isolated one. With some input filtration perhaps? Yeah, it looks like the usual arrangement. I wonder if these two capacitors are coupled by this inductor. Yeah, it's interesting. I wasn't expecting a little switching regulator. I wasn't expecting all this either. So what's such a posh lamp doing in Poundland? Are these ones that they've cleared out because maybe they weren't lasting quite as well? They panned them off in Poundland, or is it just a mass-produced lamp that you know is affordable for Poundland type stock? It's interesting. These appeared. I haven't seen them in the local shops since. I have seen the Electrek ones, and I noticed the GU10. The plastic one, they also we've taken apart the 5-watt one. They also do a 3-watt one, which I thought would do, again, like one of the other lamps where the 3-watt was just a 5-watt with a lower, smaller capacitor in it. I see a different layout here. I think it is more or less the same circuit, but it's not the exact same circuit board. It might be smaller LEDs. I'm going to take that apart later on. Yeah, this is interesting. Now I can guess that this one's going to be pretty much the same inside, but with a different range of LEDs. I have to get the top off this, don't I? Really, there is no choice, right? Back in a moment. Yeah, that took an awful lot of force, but it appears to be pretty much the same sort of arrangement here with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, same number of LEDs, just spread out a bit more. And I'm guessing from the same sort of metal enclosure here that it's pretty much the same thing again. Let's explore a little bit. What's the worst could happen? I'll whip these screws out. I don't know if it might be a slightly different metal enclosure here. Is that going to liberate? Oh, it's kind of liberating better. Oh, kind of. It's actually 2 halves. Well, that's quite interesting. With the power supply poked down a central column and trapped in by the wires at the back here, and it's absolutely covered in tape. Now, is it the same power supply? Is it a smaller power supply? Oh, it's a slightly different power supply, but I can see the choke, I can see that tiny little inductor there with I can see it's actually got the same sort of labelling on top. Yeah, it's the same sort of arrangement. So that's quite interesting that they've actually got this arrangement here. I'm quite intrigued by this sort of housing they've got here. It's intriguing. Yeah, I wonder if as it's tightened down, it squishes against the case, as it, you know, because it's in two sections, it might part a little bit. Like, oh, it is actually, it's either side of the screw holes. So that is possibly going to push down and spread against the side to get maximum thermal coupling, helped by the paste. So that's quite interesting. Yeah, interesting lamps to see actually in a place like Poundland. They're quite intriguing. Well, I've already smashed everything else up. I might as well finish the job. So here's the smashed up GU10. I shall put the tinkly bits in there and wrap them up and before I dispose of them later for safety. So we've got a capacitive dropper with a 820 nanofarad capacitor here, 400 volt, a smoothing capacitor, 6.8 megafarad, 250 volt, and just the usual support components across the back. The discharge resistor, it's rated 510k. Is that for the... yes, it is. And for the other one, across the electrolytic, it's 120k. Okay, reasonable enough. So, what voltage are these LEDs? Given this was a 5 watt fixture, let's see, what can I use to test this? Power supply. I'll set that for 12 volts. Interestingly, the plated through-hole sections, the edges, quite heavily plated through. This is arranged as a series of sort of radial sort of fins with the LEDs on them. Quite odd shapes. They're not all the same shape. This one, for instance, doesn't have as you know. They're not equal. It's not divided like a sort of like pie chart. But for heat dissipation, they've got the plated through holes at the edge, but they don't really go anywhere on this side. They're just actually on just a pad that surrounds the hole. So it must just be to concentrate the heat at the edge of the circuit board to spread it onto the glue at the side of the thing. So let's take a look at what I can do here. So I can hook onto, let's hook the negative onto this lead, and we'll see what voltage these LEDs are. That's negative. Resistor. I need a resistor to limit the current initially. 120 ohm, brown, red, brown, that'll do. That's set to 12 volts. So I've got that going up to here, goes up there, and then onto, oh right, there we go. So lighting, it's definitely within the 12 volt range, the LED. The other one has used multiples of chips. Let's turn the voltage down until it starts going out. Okay, it's now virtually out. So I'm going to bypass the resistor now and just nudge it up until I get about 20 milliamps in the display, which will give me the voltage and give me an indication of how many chips are in these. So that's just barely glowing at the moment. That's 7 volts. Nudging it up. It's getting brighter. And at about 20 milliamps, it's showing 9 volts. So that's 3 chips in that, 3 times 3. So each of these contains 3 chips. So for the dissipation, the power, what's that current is it going to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 LEDs times the 3. 18 LEDs times, well, 9 volts across them all. 162 volts, that's wild. That's quite high. So 162 volts, I equals P over V, so 5 divided by 162 equals about 30 milliamps. So that each of these packages then is dissipating about 90 milliwatts. That doesn't seem too bad. 90 milliwatts, it just seems like, hold on, 18 times, oh that's completely wrong. Right, let's try that again. So I reckon there are 18 LEDs times the 9 volts equals 162. I equals P over V. 5 watts divided by 162 equals 30 milliamps. Oh, right. Okay. Oh, no, that is about right. That's odd. 30 milliamps times the 9 volts of each LED. All right, each is dissipating about 0.3 of a watt. When that's multiplied by the 18, that should be close to the 5. Yes, it is, 4.999. Okay, that's good enough. So, yeah, it's not actually too bad. It's not really hammering them. It's quite an odd heat transfer method at the edge. I wonder if these LEDs are going to be a standard, these lamps are going to be a standard thing in Poundland. It's right at the moment they seem to be bringing out all these random lamps. It's almost as if they're experimenting to see which ones are going to go bang or which ones are going to be popular or not. So it's an interesting time. So I wonder what's going to be in there in the next visit.